idea for you guys to borrow a calculator. If you do not have one, you might want to go ahead and borrow a calculator. I got some up there, but if we do need a few more, I do have some more put away. I just don't like to have tons of them out. So I just don't have to keep sanitizing tons of them. So if anyone else does want one, you guys are feel free to borrow them. So for those of us who have the handheld calculators in person or at home, I'm going to go ahead and just kind of spotlight myself so you guys can see me bigger. What we are going to be doing is, if you guys look on your calculator, there are those buttons that you see. There are the buttons that say sine, cosine, and tangent, right? Do you guys see those buttons on your calculator? The sin, cos, and tan, right? You guys see those buttons? Right above those buttons, do you guys see how there's a little sine with a -1, a cosine with a -1, and a tangent with a -1? Do you guys see those buttons like right above? Yeah. Sam, do you see them? See the little buttons with the -1s? So above the sine, cosine, and tangent, do you see those little buttons with the -1s? Those are going to be the buttons that we are going to be using today. Those are called inverse trig. So that is sine inverse, cosine inverse, and tangent inverse. So I'm going to go ahead, exit the spotlight right now. And for those of us that have been using that Desmos calculator, I'm going to go ahead and share how you can go ahead and use those. So I'm going to just, once again, those of us who are virtual and might not have a scientific calculator, here is the Desmos scientific calculator. So you're more than welcome to use this link. You can use it on our test, final exam, whatever you would like. Feel free to use this as a resource. So I am going to go, we don't want to show my email. Okay, here we go. So here is the Desmos scientific calculator, and you're like, I don't see that buttons with the -1s there. What you're going to do is you're just going to go over to this right here where it says function, F-U-N-C. If you click on that, you guys see how the sine inverse, cosine inverse, and tangent inverse buttons appear. So those are these buttons right here. So once again, if you click on that Desmos scientific, you're going to go right over here to function, and then there's your sine inverse, cosine inverse, and tangent inverse. So you're able to use those buttons and follow along with our activities today. So does anyone have any questions about how to access those new buttons that we're going to be pressing today? Yes, yes. Well, not x -1. No. Do you see right above sine? Like on your calculator, the sine button? There's a sine -1, not the x -1, but you see like in green? Oh. Yeah, that's the, yeah, so we're going to do second and then sine. Okay, guys, so hopefully that is pretty good with seeing those buttons, and we are going to go ahead and jump on in and talk about what does it mean to use the inverse. Durbin, do you need a copy of the notes? Okay. I'm like, I got quite a few extras, so that's why I'm like, I don't mind letting you borrow or take one. Okay, guys, so we should be on the notes that look something like this. So for those of us who are virtual, if you guys printed them out, for those of us who are in person, if you guys could flip to where it says inverse, tangent, sine, and cosine ratios. So if you guys want to flip to where it says inverse, tangent, sine, and cosine ratios, that's where we're going to get started for today. Okay, so the big thing we want to know is that whenever we are using the inverse trig ratios, it's used to find angles. So I want you guys to write this down. Inverse means we're going to be finding angles. So if you guys want to write that big, whenever we're using the inverse, we're solving for the angle measure of a triangle. So inverse means we're using angles. And there are three different types of inverses that we're going to have. We have tangent inverse or inverse tangent. So that's the tangent with the -1. We have inverse sine. That's the sine with the -1. And we have inverse cosine, which is the cosine with the -1. So those are 3 different calculations we have. We have inverse tangent, sine, and cosine. So the big difference is that we are going to use these inverse whenever we're looking to find angle measures. So whenever we're looking to find angle measures, that's when we're going to be using inverse. So let's take a look at an example. So they want me to find the measure of angle X, okay? So note right here, they want me to find the measure of an angle. So whenever I'm looking to find the measure of an angle, I should think inverse, angle inverse. They don't rhyme, but you got to think those go together. So to figure out which inverse we're going to use, we're going to kind of go back to the same concept we've been reviewing in the past. So I'm going to go ahead and label my hypotenuse. Since it wants me to find angle X is going to be the angle I'm going to circle. Across from that angle is the opposite. And then what's left over is the adjacent. So let's see, thinking back to what we've done the past 3 days this week, Monday through Wednesday, which letter do I not need? Let's get someone to reply in the chat. Do I not need A, H, or O? Which one can I erase? Awesome, Bar, yes, we are going to get rid of Asa, Becca, and Mike. Yeah, awesome, guys. So we're going to go ahead and we are going to get rid of H. So I'm going to just be left with O and A. So we're still going to be using SOHCAHTOA. So we're still going to be using SOHCAHTOA. Let's ask someone here in person, if I have O and A, which trig ratio is it going to be? So if I have O and A, which one is it going to be? Anyone know here? Oh, Mariana got it in the chat from our virtual class. Yes, it's going to be tan. So think about it. Use SOHCAHTOA to help you guys out. Guys, remember our song, right? I even still have my posters right here. Hey, right triangle. SOHCAHTOA style, right? SOHCAHTOA style, right? Yeah, we remember that song, right? So SOHCAHTOA, O and A, that's OA. What is that with? That's with T. T stands for tangent. But guys, we are solving for an angle measure, so we are not going to just use regular old tangent. We're going to use inverse tangent. So it's just the tan, but then remember, for inverse tangent, we're going to just put a little -1. And to be honest with you, I almost think it's even a little bit easier than what we've done in the past. So we have inverse tangent right there. We want to find the measure of angle X. So I'm going to say, okay, inverse tangent is opposite over adjacent. So I'm going to do inverse tangent of 7 divided by 5. So the reason why it's 7 divided by 5 is, remember, TOA, it's O over A. O is 7, A is 5. So in your calculator, if you guys have one of these calculators right here, one of these, you're going to hit second tan. So you're going to hit second tan, so then you get tan with the little -1 in the corner. And then you're going to type in 7 divided by 5. And you should be getting 54.5 degrees. Anyone in person, does anyone need help on how to do that in the calculator? I'm going to show us using the Desmos, so you guys can see that. So I'm going to go ahead and clear this. So remember, in order to get the inverse, you're going to click over on function. You're going to hit tan inverse, and then you're going to go back to your main, 7 divided by 5. And there you go. You got your 54.5 degrees. Oh man, I didn't even share that. Oh dear. That's embarrassing. That's embarrassing. Okay, okay. Let me go back to the class meeting. I didn't even share that. That's embarrassing. Okay, so let's go back. So here we go. Sharing our, oh, maybe it's not going to work. Now it's not going to share. I don't know, teams, what's going on? No internet. Okay, there we go. Boom. There we go, there we go. Okay, so what I said is, you're using the Desmos Scientific, you're going to click on function. You're going to click on that inverse tan button. And then you're going to go ahead and type your numbers. So going back to the main, you're going to do 7 divided by 5. And there you go. You don't even need to close the parenthesis. You got your answer right there, the 54.5 degrees. Do we like using inverse? Isn't it kind of easy? That's not too bad, right? I almost think it's easier than the regular stuff. So there we go. So let's go ahead and let's practice a little bit more of this in our calculator. So if you guys want to practice using, so we did tan inverse in our calculator. If you guys want to practice typing these other ones into your calculator, let's do sine inverse of 0.19. So let's hit second sine, so you get the sine inverse. 0.19. Looks like that's going to round to 11. And then let's do the cosine inverse of 0.56. And there we are going to get rounded to 56. Technically, no. No. Becca, it's perfectly fine if you just wrote 11. Yeah, that's fine. I'm just putting it in to make it look fancy, you know. Saying it's rounded, but yeah, if you just put in 11, that's perfectly fine. Guys, any other questions about inverse before we kind of go back and do a throwback to what we've been learning in the past? Okay, so that was an introduction to inverse. Now we're going to talk about, now that we know inverse and now that we know regular sine, cosine, and tangent, we are going to do something called solving a triangle. So if you guys would flip to your next page, we have 3 more problems to go today. So we have 3 more of these problems to take a look at, and these are called solving a triangle. So the first question we're going to want to do is they're going to ask me to find the missing angle. So in this case, I don't need to use inverse to find my missing angle because I already know that this angle is 37. I know that this angle is my right angle, which means it's 90. So to find that missing angle E, I'm just going to go ahead and subtract from 180. So I'm going to do 180 minus 90 minus 37. So I can go ahead and solve to find that that missing angle is 53. So when you're solving for a triangle and they give you 2 out of the 3 angles, the fastest way, instead of using this inverse trig, is to go ahead and just subtract from 180. Now we are going to do some throwback questions. The first one I want to do is I want to solve for side length DF. So what I'm going to do is I'm going to put an X on side DF. I'm going to show that that's the side I want to find, so I'm going to just put a little X right there to show side DF is what I want to find. So remember, we use inverse to solve for angle. We're solving for a side, so we're going to just go back to what we've done in the past and use a regular sine, cosine, or tangent. So let's go ahead and let's label our triangle. So across from the right angle is the hypotenuse. Across from the angle they give me is the opposite. And then what's left over is the adjacent. Let's go to someone here live. Which side do I not need? Which one is not needed? O, A, or H? H is not needed. So let's just go ahead and let's remember. So, ka, choa. So if I have O and A, which trig ratio is it going to be? O and A is going to be which trig ratio? Tan. Awesome, Mariana. I also see it in the chat. Awesome. Yes, it is going to be tan. Awesome. So remember, this is now we're solving for a side. So for a side, we're going back to what we had done previously. We're going to just use regular old tangent. So I'm going to say tan of my angle equals, and it's opposite over adjacent, so 14 over x. So tan of 37 equals 14 over x. So let's see if anyone remembers this from yesterday. If x is in the denominator, so if x is in the denominator, is that going to be multiplication or division? If x is in the denominator, are we going to multiply or are we going to divide? Nope, it's actually the other one. It's divide. Yeah, it's divide. Oh, and Becca and Bara got that in the chat. Yeah, it's going to be to divide. What I always like to think about is like, think about you're on the bottom, like, ooh, you're sad, right? And division makes things smaller. And making things smaller is like, you want things to multiply, right? So bottom, divide, top, things are getting bigger. You're going up to the top, multiply. So, I don't know. We'll go ahead and do this. So we'll say here, x equals 14 divided by tan of 37. And I'm going to type that in my calculator, 14 divided by tangent of 37. I want to round that to the nearest hundredth, so I'm going to get 18.58. So the next part of the triangle, so Becca, it's actually really confusing because the problems like always change what you're rounding to. So in this case, it didn't say anything, so I went with the hundredth. But if you see like in the next example, it says round to the nearest tenth. So I would say like just be careful about what it's saying. And then otherwise, a lot of the questions on the test are going to be multiple choice. So like whatever answer you get, it's like, you know, they're not going to be, you know, one's rounded to the hundredth and one's rounded to the tenth. So now we want to find DE. So I'm going to go ahead and erase this side right here. I want to find DE, so I'm going to call that side Y. So I'm going to make side DE Y. And now you'll notice that side DE, that was the hypotenuse. So for this problem, I have Y by the hypotenuse, the opposite by 14. So if I have opposite and hypotenuse, which trig ratio is that going to be? Opposite and hypotenuse is going to be O and H, that's going to be so, right? That's going to be sine. So I'm going to say sine of 37 equals 14 over y. And if the variable's in the bottom, we're going to divide. So we're going to say y equals 14 divided by sine of 37. And so that's going to be 23.6. So that was a throwback solve for the triangle. Remember, we were solving for missing side length, so we just used regular old sine, cosine, and tangent. We're going to do another one of these, and then our last example for today is going to go back to using some more of those inverse. So for this problem right here, though, the first thing I want to do is find the measure of angle C. So to find that, I'm going to do 180 minus the 90 minus 64. So the measure of angle C is going to be 26. And we want to solve the whole triangle, so now I need to find these two missing sides. So guys, you can use any variable. I like to just make my first side X and then just make my second side Y. But if you want to use like Q and V or, you know, Z and X or whatever letters you'd like to use, you can totally do that. I'm just going to go ahead and I'm just going to make BC X. And I'm going to go ahead and label this up. So hypotenuse, opposite, adjacent. So I'm labeling that triangle. Sorry if that's a little small for those of us. It's okay for you guys to see that. It's a little small. It's not that bad. So I can get rid of my hypotenuse because there's nothing there. A is by 21, X is by O. So if I think of so, ha, toa, I have O and A, so that's going to be tangent. Okay, so here we have tangent of 64 equals X over 21. So then if 21 is in the bottom, that means I'm going to go ahead, or sorry. So if X is in the top, variable on top, that means I'm going to multiply. So X is going to equal 21 times tangent of 64. And this says to the nearest tenth, so that's going to be 43.1. Now that I found BC, I'm going to go ahead and erase all this stuff here. Now I'm going to want to find AC, so I'm going to put a Y right there. AC, remember AC, that's across from the right angle, so that is the hypotenuse. So now I have A by 21 and Y by H. So now I have A and H, which is ka. A and H is ka, so I'm going to have cosine of 64 equals 21 over Y. Variable in the bottom, I'm going to divide. So that's going to give me that Y is 47.9, and then X is going to be 43.1. Any questions so far in solving the triangles? Because we're going to have one last problem, and this time when we solve our triangle, we're going to need to use the inverse, because we're going to have to find two missing angles. So for my last example, this is our last problem of today's notes, because you'll see tomorrow is going to be elevation, angle of elevation and impression. So for this last problem right here, where we want to go ahead and solve the right triangle, we're going to want to find these angles. Now notice here, I need to find two missing angles. And so since I need to find two missing angles, I can't just subtract from 180 because there's only one angle that I know, so I'm not going to be able to find the others. So at this point, in order to find those missing angles, I'm going to need to use inverse. I'm going to need to use inverse. So let's go ahead and let's label it. So for angle A, across from angle A is the opposite. Across from the right angle is the hypotenuse. And then what's left over is the adjacent. So the side I don't need is going to be H. So for angle A, are we going to use SO, CA, or TOA to find the measure of angle A? Is that going to be sine, cosine, or tangent? Which one do we think? Tangent, absolutely. But we want to find an angle, so it's not just going to be regular old tan. It's going to be inverse tan. So I'm going to say tan inverse 12 divided by 10. So notice these questions are different than the ones we had before, where we used tan, because those were solving for side measures. In these first two problems here, I want to solve for the angle measures. So I'm going to do inverse tan 12 divided by 10. And I guess I'll just round this to the nearest 100. Yeah, we'll just say inverse tan, that's going to be 50. Round it to the nearest degree. Now when I want to go ahead and find the measure of angle C, 10 is now my opposite, and 12 is my adjacent, right? Remember when I switch my reference angle, the hypotenuse stays the same. So for angle C, it's still going to be tan. So to find the measure of this angle, I'm going to use tan inverse, opposite, divided by adjacent. So tan inverse 10 divided by 12, I'm going to get 40 if I round it up. And then to check your work, you can always test to make sure all the angles add up to 180. So I have this angle, we have the 50-degree angle, we have the 40-degree angle plus the 90. Those all added together do equal 180. So to check your work, you could always check to make sure your two angles that you find plus the 90-degree angle that you had, make sure that they all add up to 180. So that's kind of a good way you could check your work on these problems. And then the last thing we want to do is we want to find AC. We want to find the hypotenuse. On this problem, you're going to want to go ahead and use Pythagorean theorem. So you're going to use Pythagorean theorem in order to find the hypotenuse. So I'm going to get that that's equal to 2 square root of 61, or as a decimal, that's going to be 15.62. So now that we have that all figured out, that was our last question for today. So tonight, let me go ahead and share what our homework is going to be. So for our homework for tonight, you guys are going to go ahead. It's actually quite easy, the questions. The first two are like the calculator practice. You guys could probably get this done quite fast. The first two are just the calculator practice where you're just using the inverse to find B and W. And then for numbers 3 and 4, you're going to just use the inverse to find the missing angle measure. So I did just also want to highlight, guys, that in our team, you guys did have the geometry unit 3 concept check period 2. That was a 10-question multiple choice assignment. Over half the class has not completed that assignment yet. So if you had not had a chance to finish that, please do that today. I am going to go ahead and end class now. So you guys have 15 minutes to work on those 2 assignments, both getting the concept check done, as well as working on those 4 inverse homework problems. So for those of us that are here in person, you should probably get out your surfaces and try to work on getting those, or get out your devices so you can work on getting those done. So we have that. Do you guys have any other questions? I'm going to go ahead and end the recording right now.